So now we have a couple 470 ohm resistors limiting current for a red LED right there. That's because we have 14.6 volts at the supply, and I would like to use a 1000 ohm resistor, but I think that would get us a little too hot of a 1000 ohm resistor. And there's the schematic right there, but we're not going to dwell on that in this short right there. So we got about 14.6 volts, and there you can see we got about 12 milliamps of current, which is not too bad for lighting a red LED. I think we're actually a little bit higher. We'll do the math in upcoming shorts or later in the video if you're watching the full video. So, in any case, main takeaway is though, we're getting about 1000 ohms of resistance right there, but it's two resistors. So they're splitting up how much voltage is across each of them. And so for the current going through them, they don't have as much voltage across them as a lone resistor would. So they're not going to get as hot. So now we come to the schematic. We have a battery here. Let's just say it's a 12 volt lithium iron phosphate battery. When they are being recharged, they typically have 14.6 volts being applied from the charger. That's not their fully charged voltage, but that's what the charger applies to them. So I would like a 1000 ohm resistor to get a nice bright red LED with the remaining 12.6 volts, because remember it drops about 2 volts. But it would get too hot. It would have about 12.6 milliamps of current times 12 volts. So instead, I just have two resistors. There are 510 resistors, but 470 is more common, and so I use them here. But they're about 500 ohms. But in any case, the main takeaway is they're going to let the same amount of current through basically as a 1000 ohm resistor, but there's two of them, so they're going to divide the voltage in half. Therefore, they're going to have half the voltage of a lone resistor across each one of them, so each one of them is going to get half as hot. So now we'll zoom into the part where I did the math. If we have a 14.6 volt charger attached to this battery, charging the battery, and then the red LED drops about 2 volts right there. So when it comes to setting the current, if we use two 470 ohm resistors so that they divide up the voltage, we'll have a total still of 940 ohms, a little less than 1000 ohms. But in any case, when you do that math, that 12.6 volts across the resistance, we're going to get about 13.4 milliamps of current, approximately, right there. But now, the supply voltage is split up between the two of them. So each one of them only has about 6.3 volts across them. So we got the current going through them, and each one of them is going to heat up to about 0.084 watts. That's how much power it has to dissipate. So that's still, you know, somewhat warm, but that's not anywhere close to dangerously warm. So that's a pretty good way to go versus a single 1000 ohm resistor. So now we have this other note that I put here. I'll go into more detail. I pointed at this number. This is the voltage we could have with a 12 volt lithium iron phosphate battery if we're using one to power like this. When the charger is applied, because that's the voltage the charger applies. Without the charger, that much voltage won't be on there. Once we remove the charger, the battery is going to go down to 13.6 volts. Well, it is fully charged. And then, you know, if you got a big load, it will pull it down more. But with no load, that's what it'll be resting. And then you kind of want to stop using it at 12 volts. That's my recommended. Below 10 is dangerous, but 12 volts, it's pretty well drained. Might as well stop using it right there. So we want a circuit that can work in this full voltage range. But for safety reasons, we need to be careful with the maximum voltage. So that's why I got two series resistors to divide up the voltage so that each one of them only has to dissipate half the total power. So now, to end this short series, when you hear somebody talking about voltage and stuff, if you're not sure exactly what they mean, you should always take voltage measurements for yourself. So we'll do that now. So we're pretending like we're powering this with a 12 volt lithium iron phosphate battery. Well, it is attached to a charger, which provides about 14.6 volts. The red LED drops about 2 volts, right there, as you can see. Now, I'm going to do this on purpose, but I accidentally did it earlier. Putting the meters backwards, you just get a negative voltage, the meter probes. Be aware of that. But in any case, we have about 12.6 volts across the two resistors right there. So they're about 1000 ohms total, and a single resistor would get a bit hot. That's why I put the two of them there. So each of these resistors now, since they're in series, will have half of the supply voltage. So they're letting through about the same amount of current as a 1000 ohm resistor, but they're splitting up the voltage, so they're going to get half as hot.